Oops. Okay, we're going to do our second lesson on multiplying and dividing radicals. One multiplying, one dividing. Well, to multiply radicals, simply all you have to do is multiply everything that's inside the radicals. So let's say I had this problem. What I would do is multiply 12 times 6. So these guys get multiplied together. You get 72. And then we're going to multiply. Let's do it in another color. Then we're going to multiply x to the 5th times x to the 4th, and that gives us x to the 9th. Okay, well, that was easy enough. Let's put a nice little radical sign over everything. Okay, so we get this nice radical. So it's 72 x to the 9th. Well, then we go on to simplifying, which we learned how to do in our last lesson. So we're going to take this 72, split it up into 36 times 2. We're going to multiply. We're going to keep doing our prime factorization. We get 9 times 2, and then 3 times 3. Woo! That was some work. All right, who gets out of jail? We got these 2 3s that get out of jail, and we got these 2 2s that get out of jail. So, moving along, we're going to write our little jail out. There's our radical jail. Who got out? We got a 3 who got out and a 2 who got out. Who's stuck in jail? This little guy right here. He doesn't have any partners, so he's stuck in jail. Then, once again, this is our exponent of 9 right here, so we have to divide that by our index, which since it's not written is 2. 9 divided by 2 is 4, so 4 x's get out of jail, and we still got 1 x left in jail. Almost done. We multiply this outside part, we get 6 x to the 4th, and inside jail we get 2x. And that would be how you multiply radicals. So just multiply everything that's inside those jails, those radicals, and simplify from there. Let's try dividing. Okay, this is a nasty looking one, okay, but I think we can handle it. The first thing to do is remember this. So you remember this, okay? That if it's a radical over a radical, you could just write that as everything under one radical. How is that going to help us? Well, let's look at this one. We're actually going to rewrite this one. We're just going to put everything under one big old radical, okay? So we have our 10 over 2 on the outside. Those are both outside the radical, so we're going to put those on the outside, okay? And we're going to rewrite everything inside the radical here. So it's 200x to the 6th, y to the 12th, all over 5xy to the 7th. From here, what do? Well, I think it'd be cool to first simplify the outside. 10 divided by 2 is 5. So let's just simplify the outside. And then we're going to simplify the inside. So everything inside the radical, let's do a little simplifying on, okay? So let's see. We could do 200 divided by 5, which, let's see, 200 divided by 5, that would be 40. Beat you to it, didn't I? X to the 6th divided by x is x to the 5th. And y to the 12th divided by y to the 7th is y also to the 5th. From here, we just simplify. So this becomes, well, let's go back to doing our little splitting. So let's do our prime factorization. We got, this is, I like 4 and 10. Let's do 4 times 10. This is 2 and 2. 2 times 2. And this is 5 times 2. Who gets out of jail? These guys, because there's 2 of them. These guys are stuck in. So we're going to bring our guy over here. Let's write this again. So we got 5 is already there. Times, well, these 2's just got out of jail. And who's stuck in jail? Well, 5 times 2. Okay? Let's go back to our exponents. We got x to the 5th. So when we divide that by 2, remember there's an implied 2 right there. 5 divided by 2 is 2. Leaving 1 on the inside, and same thing with our y. 5 divided by 2 is 2, leaving 1 on the inside. Alright, we're going to simplify by multiplying everything out. We get 10 x squared y squared, and inside we get 10 xy. There it is, guys. Remember, this first step is critical, okay? We had to rewrite everything under one whole radical or one jailhouse, and then simplified from there, okay? Alright guys, well done, and don't listen to your headphones too much. too loud because you might go deaf.